All right, so also on 4.2, the first one we did, remember there's three things that are going to happen in chapter 4. They're either going to meet at one point, which happened in our last video, and we get an answer, x and y, or they're going to become parallel, which means they're no solution, never going to intercept, or the third option that might happen is that they become the same line, which makes them infinite solutions. So let's see what happens with this one. Practice 5. Oh, it has a fraction. That's okay. All right, so again, the goal in substitution method is to get one of your letters all by itself. Well, if you'll notice in our second equation, it already has x by itself. So we know that x equals this. Remember, it's a more than one term. We got to put it in parentheses because that whole x is that thing. All right, so since this one's already set for x equals, let's bring over our first fraction, 1/4 x minus y equals 2. Again, we know that x equals this in the second equation, so if x equals this, then in place of x in our second equation or our other equation, we're going to plug in this expression. So we're going to have 1/4, and then our x equals this whole expression, 4y plus 8 is our x. Make sure you bring down the rest of your equation, minus y equals 2. So we still have this first equation, except in place of x, we plugged in this expression that we did with our second equation. All right, so we have 1/4 times this minus y equals 2. Then now you have a couple of options here. You can leave it as a fraction, and I'm going to go ahead and do this as a fraction. We're going to distribute this 1/4 into the equation, so we now have 1/4 times 4y, or 4y over 1, plus 1/4 times 8, or 8 over 1, minus y equals 2. All right, so I'm doing the little baby terms because I want to refresh your memory on fractions. Okay, so when we multiply fractions, you multiply a fraction by a whole number, you got to turn your whole number into a fraction by putting it over 1. Now remember, you multiply straight across, or you can also cross cancel because you have to always reduce your fractions. So right here, there's a 4 on top and a 4 on bottom. These 4s are going to cancel out and become 1s. 4 goes into 4 once, 4 goes into that 4 once. So now we have 1 times 1y, which is just y, and then 1 times 1, which is just 1. We don't need the 1 on the denominator, though. So we just have y. Y plus, well, same thing here. What are they both divisible by? They both are divisible by 2, but they're also divisible by the bigger thing that they're divisible by is 4. So I'm going to divide them both by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So this 8 becomes a 2, and this 4 becomes a 1. Now it's just 1 times 2, which is 2, and then 1 times 1, which is 1. And again, I don't need the 1 on the denominator. So we just have y plus 2. Bring down the rest of my equation that I've not used, the minus y equals 2. And then what are we going to do? We're going to combine our like terms, right? We have a 1y minus a 1y. What happens here? Uh-oh, they're going to go away. So we now have 0y plus 2 equals 2. Solving algebraically, we're going to get the 2 on the other side. We're going to subtract 2 to both sides because we're going to get to do the opposite. And we have 0y equals 0. Everything went away. When everything goes away, these are the same line. These are the same line because everything canceled out. Everything went away. So these are the same line. Therefore, if they're the same line and everything cancels out, what's my answer? Infinite solutions. So when everything cancels out, your answer is infinite solutions.